Right. So 8.1 was basically multiplying rational expressions. So in that rational expression, if there's anything that can be factored, you want to factor it. Once you factor it, you want to write your restriction. Restriction is basically only from the denominator, because you want to write the restriction before you simplify. And once you simplify, you want to multiply, right? Multiply. How do you multiply? You multiply top to top. Anything in the top, you multiply them with each other, and then you multiply bottom to bottom. Yes, everybody clear about how we multiply rational expressions? This one is pretty straightforward. Okay. Adding, subtract. That was 8.1. 8.2 we moved on to adding and subtracting. Adding and subtracting, again, the first step should always, and then it also had complex fraction. We'll get to the complex fraction part in a minute. Adding and subtracting, again, if anything can be factored in the numerator and the denominator, please factor it. Everybody good? Once you factor it, you write your restriction, factor and write the restriction. After you factor and write the restriction, when you're adding and subtracting, what do? How do you add and subtract rational numbers or just fractions?
Denominator the same.
Same denominator, perfect. And how do you find the what do you do to find the common denominator? Find the LCD. Find the LCD. How do you find the LCD? List all the factors except no repeating ones. So if x plus 1 occurs twice, take it only once.
And then is it if you have to choose between x and x squared?
You choose x squared, because x squared already contains an x. Yeah, correct. Okay, list all the factors except no repeating ones, right? Don't eliminate the repeating ones. So find the LCD and make sure, convert all fractions to have the LCD, and then you add by making sure same LCD. So you add, basically you add the numerator. The numerator needs to be added, but the denominator should be the same LCD. Denominator should be same LCD. Does that make sense? You add the numerator by making sure all the fractions have the same denominator. Is everybody clear about what we just did? So that is for adding and subtracting. That is for adding and subtracting rational expressions. But what about complex fractions? How do you for complex fraction, your goal is to, what's your goal when you're shown a complex fraction? What is your goal? Simplify. That's your goal. That is what you want to do. How do you simplify? How do you simplify a complex fraction? Go ahead. What's the first step?
Factor it.
Yeah, factor it. Yes, that goes without saying. But the main thing is for you to find the LCD, and for you to find the LCD, you have to factor. So I'm not even going to talk about that. The first thing is find the LCD of all the fractions that exist. Right? Everybody good? So this, I feel from now on is when I felt students on the quiz didn't do that well because they forgot what to do. So make sure for a complex fraction, find the LCD, but you have to factor first. She's absolutely right. Factoring goes without saying. I'm not even writing that anymore. Because you have to factor for you to be able to find the LCD. I hope we all know that by now. Take the LCD of all the fractions of the numerator and the denominator. Step number 2, multiply the top and bottom with this LCD. Do you guys remember this? When you multiply the top and bottom with this LCD, you will find that when you distribute, you will get it will simplify. You distribute and you simplify. Okay, and these steps are there in your notes. If at any given point of time you want to go back and read your notes in details, it's there. But I just wanted to make sure that we have it together. While you're writing this about complex fraction, do we all know how to find the restriction of a complex fraction? Restriction of the complex fraction basically comes from all the denominators, numerator, denominator, as well as the denominator, as well as when you find, so as well as in the last step. Once you simplify, sometimes you'll have a denominator that's different from what was existing. So keep in mind the restriction comes from all of it. From all of it. Okay, going on to solving. Solving is sort of similar to complex fraction. I mean, if you can cross multiply, cross multiply. If cross multiply is possible, cross multiply. But remember that's not always possible. Cross multiply possible. Do that. But if cross multiplication, if not, do you guys remember how to solve a complex fraction? Go ahead, yeah.
You take the denominator of every.
Correct, perfect. The same thing. You're going to find the LCD of all the fractions, left hand side and right hand side, of all the fractions. Left hand side and right hand side. Okay, so of all of it. Once you find the LCD, once you find the LCD, what do? Multiply. In here you multiply top and bottom, but for rational expression there's no top and bottom, there's left hand side and right hand side. So multiply left hand side, multiply left hand side and right hand side with this LCD. And then what do? This, so you remember you multiplied the left hand side and the right hand side, so there will be parentheses because the left hand side could have multiple terms, the right hand side could also have multiple terms. So if you're multiplying both the sides, you have to distribute to each of the term. So distribute and simplify, because when you distribute, what happens is all the denominators will get cancelled, and you distribute, should be left with no longer will you have a rational expression, you will have a polynomial. Polynomial means linear, quadratic, any of those that you know how to solve. And then you solve the polynomial. Is everybody clear? Okay, going on to the next section, which is 8.4, composite functions. Basically, the composite function also had function operation, adding, subtracting. So this one was easy. It was like f of x plus g of x, f of x multiplied by g of x, and so on and so forth. So all you have to do is add two rational functions, multiply. So if you know how to add rational functions, multiply rational functions, you should be able to do it. Yes?
When it comes to open circle,
That's composite. I was just going to write that. Yeah, I was just going to. So function operation, hopefully all of us know it. It's the composite that was a little more new. And remember, we said when they ask you to do composite, a lot of times they will just say f open circle g, and this means f of g of x. And then, sorry, there's one open parenthesis. And how do you evaluate this? Evaluate g of x first. Result of this, result of g of x is input for f of x. Okay, so this is, I feel this is a little more straightforward because you have done this you've done composition in algebra 2, so it's just extending it to rational functions. Not too different, except you might land up with a complex fraction, because you'll see if you do some of the work, you'll see you might land up with some complex fraction. And remember, we also did composite functions with tables and graphs and all of that, so please go ahead and take a look at all of them. Okay. Can I go to the next one? Anyone needs a minute more? I know some of you are writing this down. If you need a minute more, just raise your hand. Yeah. Okay. You don't want to do this? I see you're doing something else.
this is from the first page.
Okay. Alright. The next section, I'll go to 8.5, was rational inequalities. We first did polynomial inequalities, then we went on to rational inequalities, but the concept is the same. Instead of trying to solve a rational equation, they give you an inequality. So rational inequality will look like this. X squared plus 3x plus 2 over x plus 5 is greater than or equal to 0. You guys remember this? What would your first step be? Always factor, that doesn't change. After you factor, what do? Anyone remembers how to do rational inequalities? If you're shown something like this, after you factor, is this factorable? I think so. Factors of 2 that are, yeah, x plus 2, x plus 1. After you factor, what do? Remember, okay, let me try to jog your memory. Critical numbers. You guys remember critical numbers? What are those critical numbers? Where do I get those critical? After you factor, where do I get my critical numbers from? Okay, Leah, go ahead.
When you set the each of the factors
To
to 0.
0. For basically the solutions of the factor. Basically, so if this factors to x plus 1, x plus 2, My critical numbers are -1, -2, and from the denominator is -5. It's the solutions of the x, right? So find the critical numbers. I'm going to write as C dot N dot. Hopefully everybody knows what C dot, as they are solutions of x from the factor. What do you do with those critical numbers? Okay, before we go to critical numbers, write the restriction also. Right, because that will help us decide whether it's going to be open circle or closed circles. Once you write, okay, yeah. That's right. Okay, so I'm going to ask you next. When you find these critical numbers, what are you going to do with those critical numbers? You found the critical numbers, but what are you going to do with that? What are you going to do with -2, -1, and -5? I'm going to put it down here. I'm sure as soon as I write it, it's going to come back to you. Yeah.
Yeah, you're supposed to evaluate the...
But before you do that, how will you evaluate? You need to put them on the number line. I need to hear that. Put them on the number line and write your open circle and closed circle. And mark open circle and closed circle. I'm not going to write that. I'm going to assume you guys know what to do. Your restriction will be an open circle because you cannot have that value. And if it is greater than or equal to, it will be a closed circle. You guys remember that? Open circle, closed circle? I'm not writing it down, so I hope you remember. It's just a lot to write down. Put them on number line. Once you put them on the number line, what are you going to do? What do you do with that? You have a number line, and I think she gave me the answer. You have the number line and you have -5, -1, -2, whatever. What are you going to do with those things on the number line? Okay, again I'm going to write it down. As soon as I write it down, I'm sure it will come back to you. You test. You guys remember test? You take you take a number in each of those intervals. Test with one number in each interval. What is your goal in this testing? Yeah, the only thing, when you test, you don't care about anything except is it positive or negative. You're testing whether it's positive or negative. And then you write your solution. In the interval notation, and some of it you will have to go back and look at your notes. When I say solution, I hope everybody knows how to write the solution. Basically, if it says greater than 0, you'll take all the positive intervals. If it says less than 0, you'll take the negative intervals.
And you write it in interval.
You write it in the interval notation. And as well as you mark it on the number line. You already have a number line. So you just have to highlight your solution on the number line as well as put it in interval notation. Everybody okay? And the last one is graphing. I'm not going to spend time graphing on the whole this part. I'm not, because we've just finished graphing. We've done a few warm-ups. The only thing is make sure you know how to find the vertical asymptote, whole, horizontal asymptote, x-intercept, y-intercept, slant asymptote. All right. So vertical asymptote and horizontal whole comes from the X restriction. Horizontal asymptote is you basically take the first term over the first term. You guys remember this? I'm just giving quick reminders. First term over first term and simplify. Y equals to first term over first term and simplify. X-intercept, you set y to be 0. Y-intercept, set x to be 0. And slat asymptote, divide numerator by the denominator. You can use long division denominator.